So continuing talking about probability. So now we're going to kind of talk about different ways of displaying our events or more than one event for probability. So the first thing that we will be taking a look at are two-way tables and probability. So when finding probabilities involving two events, a two-way table can display the space in a way that makes probability calculations a little bit easier. So here's kind of an example so you can kind of see where we're going with this, right? So students in a college statistics class want to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender and whether they had a pierced ear. For all 178 people in the class, the two-way table below displays the data. So suppose we choose a student at random, we have to find the following three probabilities, okay? So we'll define event A as being a male and event B having pierced ears. So let's first talk about the probability that of event B, which would be that a student has pierced ears. Okay, so there are 103 students that have pierced ears, and there's 178 students total. Then let's take a look at the probability that the student is a male with pierced ears. So we're looking at the probability that event A and event B would be true. So there are 19 males with a pierced ear or pierced ears, and there are 178 total. And then C is a male or has pierced ears. Okay, so now we would see a little bit of an overlap, right? So there are 90 males in the class. There's 103 individuals with pierced ears. However, 19 are males with pierced ears. That means if you include them both in the 90 and in the 103 individuals, you're going to end up counting them twice. So in order to figure that out, we can either add the 19 plus the 71 that don't males that don't have plus the 84 females. So kind of add the three separately, and we would have 174 that are either male or have pierced ears. Or the other way to do that would be to use the overlap to kind of subtract out, right? So you have the 90 male plus the 103 with pierced ears. So that's going to end up giving you a probability of 193 out of 178. We know that that's not possible. It's a probability over 1. Probability has to be between 0 and 1. So right away we would know that there was an issue here. The issue is that we counted 19 males twice. So if we add together the two and then subtract out the overlap, or the people that we counted twice, we'll end up with our probability that they will have one or the other when events are not mutually exclusive. So what this is the general addition rule. So this right here, so this is a Venn diagram that illustrates what's going on here, okay? So you have 90 in one circle. Okay. These are the males, right? These are everybody with pierced ears. These are males with pierced ears. Okay? And so if you add those 19 both to the males and pierced ears, okay, you're going to end up counting them twice. Okay, so this is the idea that these events are not mutually exclusive. So I said in class the other day that a Venn diagram of mutually exclusive events, your two circles wouldn't be overlapping. So it's the idea that rolling a 1 on a die and rolling a 5 on a die are mutually exclusive. You can't do both at the same time. But rolling an even and rolling a multiple of 3, 6 was that overlap. And so to not have counted that twice, if I asked you to roll an even or a multiple of 3, you'd have to subtract out that 6 one time. So that's called the general addition rule for two events. If A and B are any two events resulting from some chance process, then the probability of A or B, you add them together like you do with mutually exclusive events, but then you got to subtract out any overlap that might happen. So while we're looking at Venn diagrams, let's go ahead and talk about them. So, Venn diagrams are used in a lot of different things in mathematics and other worlds. So some standard vocabulary and notation have been developed, so we're going to talk about them there. The complement contains exactly the outcomes that are not in A. So if you see a Venn diagram should be inside of a square or rectangle. The space outside of the circle is the complement. It's whatever doesn't appear in A. Okay, and then the events A and B are mutually exclusive or disjoint if they do not overlap. So this is what I spoke about in class. The intersection of events A and B is the set of all outcomes in both A and B. So that's the overlap. Okay, so the intersection is talking about the overlap of two circles, where the union of events A and B is the set of all outcomes in either event A or B. Okay, to keep simple straight, remember U for union and N for intersection. Helps me anyways. Okay. So let's start making some Venn diagrams. So back to that example on gender and pierced ears. So we can also have used a Venn diagram to display the two-way table that appeared in that problem. So in that two-way table, you had some information, right? So you have 71. So if event A are males and event B is pierced ears, okay, you had 90 males, right? And you had 103 with pierced ears, okay? The overlap was the 19, that was A and B, okay? So have males with pierced ears, there was 19 of them, okay? And all of your numbers are here now if you think about it. 84 that have pierced ears that are not males, that means here's your 84 females that do have pierced ears. Here's your 71 males that do not have pierced ears. And this 4, so that 4, you know they don't have pierced ears and they are not males. So these 4 are the females without pierced ears. So there's a whole lot more going on in a two-way table than you would think. You don't need as much in a Venn diagram, although the display says exactly the same thing. So to show you kind of how you can read it, right? So the intersection of the two circles, like I said, are the male and pierced ears. Those are the 19. The inside circle A, the outside of circle B. So males with no pierced ears. So that's A and the complement of B, that would be the 71. The inside of circle B, outside of circle A, that's going to be the females and pierced ears, so that's that 84. And then outside of both circles is that 4. Those are the females without pierced ears. Okay, so now to look at just a quick example of another quick example of Venn diagrams, but also like how to go from a problem to a two-way table, and then from a two-way table to a Venn diagram, and then ultimately how to read probabilities from it. So in an apartment complex, 40% of residents read USA Today. Only 25% read the New York Times. 5% of the residents read both papers. Suppose we select a resident of the apartment complex at random and record which 2 papers the person reads. So the first thing that we want to do here is make a two-way table that displays the sample space of this chance process, okay? So we have kind of 2 ideas going on here, is that they read USA Today, okay, or they read the New York Times. Okay. Total. So the first thing that I want to kind of talk about is the idea of that last box. That's your complete total, right? So I mean, these are probabilities here, and they're percentages, which means that this cannot be more than 1. So that has, for it to be a legitimate probability model, that has to total 1 there, okay? They're giving these to you in terms of percent, so it's got to total 100%. Okay, so the first thing is, let's talk about what we go through here. So in an apartment complex, 40% of the residents read USA Today, right? So here's USA Today. Who reads them? 40% of them, okay? Then 25% read the New York Times. So here's yes to USA Today. Here's yes to the New York Times, which means that you're 25% there. Okay. You were also told that 5% of the residents read both papers. So that's the yes, yes, right? So that kind of lines up. Yes, yes, right here is 0.5. Okay. And then, well, that helps you out with a lot of it, right? Because if you know that that's 0.5, then you know that that's 0.35, and then you know that that's 0.2. Okay. You would also know that if who reads your no would have to be it would have to be 40%. Right, because you have 1 for the missing column for no. So you have 1 minus the 0.4. So then this would have to be 0.6 because that's got a total 1, right? And then you would know that the missing here would have to be 0.75 because that would have to total 1, right? It's 1 and 0.25 plus 0.75 also equals 1, okay? And so that just gives us one last one to fill in, which would have to be 0.4 because it has to be. Okay? And now let's take a look at what the Venn diagram would look like, which is probably quite a bit easier, faster anyways. Okay? So we have my rectangle, like that. And I have 2 events here. They either read New York Times or they read USA Today. Okay. or they don't read either, or they read both, okay? So let's say that this will be event A, and we'll say that event A is the people that read let's say USA Today. I think that's what I said before. And then we'll call this B, which is reads New York Times. Okay, the easiest thing that I think is to see here would be the 0.05% that read both, that was told to you. You also kind of have the math already in your two-way table. So if you look at your two-way table, now you're looking for the people that read USA Today that don't read the New York Times. So yes to USA Today, but no to New York Times. That's 0.35. Right? And then back to that two-way table, assuming we already did that before Venn diagram. The reads New York Times but doesn't read USA Today. So that's yes to New York Times but no to USA Today. So then that would be 0.2. Right? And so now at this point you can figure out who the no is just by adding and then subtracting out and figuring out that it's 0.4 in the null set, okay, who's not accounted. Either way, so you can find that also from the two-way table, so that's people who do not read New York Times and do not read USA Today. Okay, so now let's talk about some probabilities that we can find from our setups here, okay? So say I wanted to find the probability that a person reads at least one of the two papers, okay? So we would know this symbolically with using or, right? So they use, so they read either the probability they either read one or the other, right? So it's probability of A union B, A or B, okay? So you know that that would be the probability of A plus the probability of B. The problem being is that you have that 0.5 that read both, so you'd have to subtract out the probability of the people that do both, which is A and B, the intersection, okay? So the union is the two separate added together, subtracting out the intersection. So 0.4 read USA Today, plus 0.25 read New York Times, minus the 0.05, the 5% that read both, tells you 60% read one, at least one of the two papers, okay? And then part D, from the two-way table or the Venn, okay, let's find the probability that the person doesn't read either paper, okay? So we kind of have that right here already, right? So you're looking for the probability of the complement of A, anything that falls outside of A. Well, anything that falls outside of A would have been the 0.2 and the 0.4. And then anything also, anything that falls outside of B, okay? So anything that falls outside of A and B is only the 0.4, because anything that falls outside of B would be the 0.35 and the 0.4, and it's the 0.4 that falls outside of both of them. And that is it for video 1.